So I'm delighted to be joined today by Dave Torp. He's from Mechnano. Nice to see you again, Dave.
Thank you, Trevor. Always a pleasure to be here.
Yeah. So we spoke, I think, the first time about Mechnano was just over a year ago, wasn't it?
I think it was Apex this year.
Right, right. It's a fascinating company. You're involved, of course, in carbon nanotubes, where you can implement or introduce different properties into these carbon nanotubes to either make them stronger, increase the thermal components to them, or in the case we're going to talk about today, the ESD properties.
Yep.
Yeah.
No, thank you, Trevor. Carbon nanotubes have been around for about 20 years, and the main beef on them was kind of get entangled. They like each other. They kind of entangle like a big ball of spaghetti, and then they don't really do much when you put them into the matrix. Whatever polymer matrix you're putting them into, they don't necessarily behave well. They kind of act like carbon black,
right?
And you don't get any of those properties that carbon nanotubes are known for. So the core competency of Mechnano is basically taking those carbon nanotubes, cleaning them up, getting all the residual junk off it, contaminants off it, catalysts off it, debundling them, and then functionalizing them so they integrate with the polymer and engage with the polymer to give you those desired properties. So that's where the core competency of Mechnano comes in, is in that functionalization to make sure that we generate materials that have the properties that our customers want. Our first entree to the industry was Formula One, which is a very rigid photopolymer, and it has been very well received by the electronics industry, who's very concerned about ESD.
Okay.
And those ESD parameters, back in our day, was TTL logic or CMOS, and it was, 5 volts, and, you could... it was pretty robust. Today, the chips are getting much, much bigger, and they're becoming much more sensitive. So if you have a transport carrier on your semiconductor manufacturing floor that has some excursions in terms of ESD performance on the tray, zap goes the chip, and you get frowny faces and negative vibes coming from the manufacturing engineer because they just blew a $100,000 chip, and there's some negative feelings about scrapping those high-end chips. So with the lower voltages and the larger chips, there's been a discovery that sometimes good enough wasn't good enough, and so the Formula One was primarily designed to take care of some of that ESD non-uniformity within the JEDEC trays and all the component carriers that were going on. Our next generation of product was the C-Light product, which does a good deed for the EMS guys. And what I mean by that is it can take the wave soldering temperatures, it can take the surface mount temperatures. So
that's for pallets that are going through thermal excursions.
You can cure them in a adhesive curing operation. So the C-Light material is becoming very popular in the EMS community for the surface mount assembly and the manufacturing aids, the positioning aids that are used on the factory floor. We have found other customers. They like our stuff. They want more. They want different properties. And so what we have been able to do is adjust the electrical conductivity, the surface resistivity, the bulk resistivity of the product. So if you want a 10 to the 6th, if you want a 10 to the 7th, 10 to the 8th, we can dial in pretty much within one order of magnitude. If you look at the current state of art in the industry, it's usually 2 to 3 orders of magnitude. So the nano uniformity that the carbon nanotubes give in those particular applications is huge advantage.
So it gives it a real stability and homogeneous type of
it gives you nano-uniform properties throughout the entire entity, whatever the entity is, whether it's a tray, a part, a fixture, a tool, a handle, it doesn't matter. But you got that nano-uniformity, and that's where the differentiation starts to become what I'll call a value add for a lot of our customers. In addition to that, we have customers who say, hey, Dave, we like your stuff, but it might be a little bit too brittle for us. So we've created other products in the product line to accentuate the family, to say, okay, we have a little bit tougher product, we have a little bit more flexible product. So
I think you've got a few samples of that here, have we?
A few samples of that. So,
so
a little demonstration that, this is the Formula One product. It's relatively rigid.
Yeah, very. Yeah.
But it's extremely precise. You can hold extremely precise dimensions on this particular material. So the nano uniformity is there, but you're holding extremely tight tolerances. And for 3D printing, that's kind of the...
You need to have that, accuracy.
You need to have that.
Yeah.
But occasionally, if you hit this with a hammer, and some of our friends and some of our manufacturing floors do not treat the nanotube enforced materials like with kit gloves. Yeah. So that's why
So what happens if you hit it with a hammer? Does it shatter?
It's gonna it's a little bit more crystalline, and it will crack if you hit it with enough force.
Right.
That's why we created the tough material, and you can kind of see that there's a little bit
of
more
inflection
bend,
there,
a little bit more flex. And so for some of the applications that require force fitting or tight fits or whatever, the tough material...
it's got that little bit of pliability.
It has a little bit of pliability, and it can take a little bit more beating than the rigid material, which is the Formula One. And then we have the Gumby material. This is the flex material. So this will bend and twist and basically conform to a surface. So when you have things like what I'll call caps that need to cover components during like a conformal coating operation, you can 3D print the boot that goes over, a cover that goes over. And so on the conformal coating operation, or when you need to protect a very sensitive device for handling, you can put a boot over the device so you don't break that device while you're doing your electronics assembly. So most of the materials that we have been developed for what I'll call manufacturing aids on the factory floor. They're not necessarily direct end-use products that go into end-use applications, but they're used as manufacturing aids, which is the easiest point of entry. We are working with a few of the national labs and a few defense contractors on more advanced parts going into space applications and stuff, but those require a relative amount of due diligence and a relative amount of testing. So we are very pleased with the results thus far, but we're anticipating it'll be a little bit longer before we're out in space applications and such. I think there's a huge number of potential applications for the technologies that you're working on. But going back to this the example you just showed us, I mean, you achieved this by introducing just a few elastometers into the compound. It's different base plastics that we're using. So the base material that we use has flexibility already built into it, and we're loading it with a certain percentage of nanotubes to give the electrostatic dissipative properties.
Okay, excellent.
So it's basically we're choosing different polymer systems. They already have flexibility built into them, and then we're enhancing them by functionalizing the carbon nanotubes for those particular polymers. Right. And that's the core competency. That's the PhDs behind the wall, behind the curtain, modifying and functionalizing it for that particular polymer.
Right. Now companies that are looking to use this material for pallets and trays and things like that, do they come to you and you make them, or are you licensing the technology to companies that make pallets and trays?
We do quite a few things. We partner with what we call service bureaus who do 3D printing, contract 3D printing for a living. So there's a lot of folks out there who do contract 3D printing for a living. We partner with those guys. We also partner with the equipment companies. So the guys who make 3D printing equipment, and there's a plethora of them, but our material is being qualified on several pieces of equipment. The latest one was the Arbor Freeformer, which we take some polycarbonate material. They use the polycarbonate pellets, and they put it in their 3D printing system and
make whatever they like.
Make basically whatever they desire. But for them, what we provide is ESD uniformity. So in cases where there is some type of fastener that is required, a clip, something of that nature that comes into contact, the ESD requirements, it gives them a new market space to basically play in. And, where the traditional polycarbonate is not, electrostatic, dissipative, our enhanced polycarbonate is electrostatic dissipative. And we do see the future as in additional materials.
Yes.
So ESD was our, what I'll call step into the water, toe into the water. We're working on EMI, RFI shielding materials, and you start to combine the flexibility of material with EMI
RF,
performance, or RFI performance. It starts to become pretty exciting, and we're working with some partners on those materials as well. So pretty exciting.
Yeah. No, I think you're just at the tip of the iceberg. The very, baby steps on this, but I think it's huge potential. It's a very exciting space to be in, and I want to, keep a close eye on you, of course, Dave. But we'll want to thank you for coming in and telling us about it today.
Thank you. Pleasure to be here, Trevor.
Good.